Welcome, energy enthusiasts, to a captivating exploration of the future of power distribution. Today, we embark on a journey into the fascinating realm where cutting-edge technology meets the vital infrastructure that powers our world. Our focus? The incredible synergy between artificial intelligence and smart grids. Imagine a world where the way we generate, distribute, and consume energy is not just efficient, but intelligent. That's the world we're stepping into today, where AI algorithms are catalysts for transformation within our power systems. These algorithms are more than lines of code. They're the architects of an energy landscape that's smarter, more adaptable, and better equipped to meet the demands of our ever-evolving society. As we delve deeper, we'll uncover the intricate dance between AI and smart grids. We'll see how AI's ability to crunch vast amounts of data in real time breathes life into the concept of predictive maintenance, ensuring that power outages become a thing of the past. The mesmerizing art of load forecasting, powered by AI, paints a picture of a grid that anticipates our energy needs, optimizing power distribution and reducing waste. But that's not all. We're venturing into the realm of renewable energy integration. AI, like a conductor guiding an orchestra, harmonizes the fluctuations of wind and solar power, making them not only viable but integral parts of our grid. And as we navigate the terrain of microgrid management, AI emerges as the navigator, steering power flow with unprecedented precision. Hold onto your seats as we explore AI's prowess in maintaining the delicate balance of voltage and frequency. Imagine a symphony where every note is perfectly tuned and every instrument plays in harmony. That's the grid AI envisions and orchestrates. Cybersecurity takes center stage as we reveal how AI stands guard against digital threats, ensuring the safety of our interconnected power systems. And let's not forget the dynamic pricing choreography, where AI conducts a dance of supply and demand, giving you more control over your energy consumption. Lastly, we'll unveil how AI shapes the future by aiding grid planning and expansion. Think of it as a futuristic city planner, using data to design a power infrastructure that anticipates the needs of generations to come. So, if you're ready to be captivated by the fusion of AI and smart grids, join us on this eye-opening journey. Together, we'll unravel the intricate threads that weave a tapestry of innovation, efficiency, and reliability in the realm of energy distribution. Welcome to the future of power. Let's dive in. Artificial intelligence, AI, algorithms are playing a significant role in enhancing the efficiency and reliability of smart grids for energy distribution. Smart grids leverage advanced technologies to monitor, control, and optimize electricity distribution, and AI algorithms are crucial in making sense of the vast amounts of data generated by these systems. Here's how AI contributes to improving smart grids. Load forecasting and demand response. AI algorithms analyze historical consumption patterns, weather data, and other variables to predict electricity demand accurately. This helps utilities optimize energy generation and distribution, reducing the risk of overloading and blackouts. Demand response programs can be initiated based on these forecasts to incentivize consumers to reduce their consumption during peak periods. Anomaly detection and predictive maintenance. AI algorithms monitor the grid infrastructure in real time, identifying anomalies, faults, or potential failures. Machine learning models can learn from historical data to predict equipment failures before they occur, allowing utilities to perform proactive maintenance, minimizing downtime, and reducing operational costs. Optimal energy distribution. AI algorithms optimize energy distribution by analyzing data from sensors placed throughout the grid. These algorithms determine the most efficient routes for electricity to travel, minimizing losses and ensuring that power reaches its destination with minimal disruption. Integration of renewable energy. AI helps manage the variability and intermittency of renewable energy sources like solar and wind. Machine learning models can predict energy generation from these sources, enabling utilities to balance supply and demand effectively. Microgrid management. AI assists in managing microgrids, which are localized energy systems that can operate independently or in conjunction with the main grid. AI algorithms optimize the energy flow within microgrids, making decisions about when to use stored energy, when to draw from the main grid, and when to generate energy locally. Voltage and frequency regulation. AI algorithms can regulate voltage and frequency levels in real time, ensuring a stable and reliable power supply. This is crucial for maintaining the quality of electricity delivered to consumers and preventing equipment damage. Energy theft detection. AI can analyze consumption patterns and identify deviations that might indicate energy theft or meter tampering. This helps utilities detect and prevent fraudulent activities, ensuring fair billing and revenue protection. Dynamic pricing. AI algorithms can analyze real-time data to implement dynamic pricing models. This means that electricity prices can vary based on demand and supply conditions, incentivizing consumers to use electricity during off-peak times when it's cheaper. Grid planning and expansion. AI aids in long-term planning by analyzing demographic data, consumption trends, and infrastructure conditions. This information helps utilities make informed decisions about grid expansion, upgrades, and infrastructure investments. Cybersecurity. AI can play a role in enhancing the cybersecurity of smart grids by identifying unusual network activities, detecting potential cyber threats, and helping utilities strengthen their defenses against cyber attacks. In summary, AI algorithms provide smart grids with the intelligence needed to optimize energy distribution, enhance reliability, reduce operational costs, and enable the integration of renewable energy sources. By leveraging AI's analytical capabilities, utilities can better manage the complexities of modern energy systems and provide more efficient and reliable services to consumers.